Welcome to Pomodoro Joe. Today is Monday, May 1st, 2023. Today we're looking at LeetCode problem 1491. Average salary excluding the minimum and maximum salary. This is an easy problem. You're given an array of unique integers, salary, where salary index I is the salary of the ith employee. Return the average salary of employees excluding the minimum and the maximum salary. Answers within 10 to the negative fifth of the actual answer will be accepted. All right, and then we have some salaries between, we have at least 3 salaries, no more than 100 salaries. And our salaries range between 1,000 and 10 to the fifth. So, all right, let's get started. We'll put 25 minutes on the Pomodoro timer, and here we go. And there we go, one line. So how does this work? Well, we are going to return the sum of the sorted salary from the first element to the last element, or I should say from the second element to the second to last element. So we're going from element 1 to element -1 not inclusive. So by sorting the salaries first, we have the minimal salary at the beginning and the maximal salary at the end. So if we remove the first value from our sorted salary, that is removing the minimum salary. And if we don't include the last element of our sorted salaries, which is the maximum salary, that's effectively removing the minimum and the maximum salary. And now we're taking the sum of that entire thing, and then we're dividing it by the length of our salary, so that's the number of elements in salary, but minus 2 because we're excluding 2 elements, the minimum and the maximum. So that's it. Let's see how we do. And we pass. We don't do very well for runtime. We beat only 5% for runtime and 8% for memory. So this one-line solution, while it's simple, single line, doesn't do great in terms of our runtime or memory. All right, this is sort of the Pythonic way of doing it. It's very simple and it's one line. It's a little bit complicated to read though. So I'll go back, I'll show you a way to do this that should work in just about any language. You might have to change the syntax a little bit, but the actual process should be the same. So in this case, we need to keep track of 3 things. We need to keep track of our current total. So we'll start that at 0. So we're going to keep track of our total, what our current minimum is, or what we expect to be the minimum value to be, and our current maximum value. So we'll keep track of the totals so far, the minimum value we've run into so far, and the maximum value we've run into so far. Now our minimum value, we want to set that to be something really large because we're only going to be resetting it when we find something smaller. So our default value will be, what is our maximum here? 10 to the fifth. So we'll go 10, 1, 2, 3, 4, and we'll add a 1 just in case. So that should be enough. And our max value, now we want to set this one to be a very low value because we'll only be resetting when we find something higher. We can set that to 0 because according to this, nothing should be under 1,000. Now we just go through every single salary in our salary list. We can add to the total, we can set our minimum and maximum values, and then we will do some calculation at the end. So I can do a for loop or a while loop. I'll do a while loop. Again, this is for demonstration purposes. So we'll start at index 0 and we'll go to the max index, which will be the length of salary minus 1 because that is a 0-based index. So while index is less than max index, actually I should say less than or equal to, our total, we'll increase this by the value at this index. So it's total plus, actually let's grab the value, make this easier on ourselves. So the value will be the salary at this index. Now our total will increase by this amount. So we can say total is equal to total plus this new value. Now we check to see if this new value is less than our current minimum. So if the current value that we're looking at is less than the minimum value we've found so far, we'll reset our minimum value to this new value. And we can do the same for the max. So now we've gone through, we've added up all of our salaries to get our total, and we've found the minimum and the maximum values. So we need to remove the minimum and maximum values from our total so far. So that's easy to do. So our total will just be our total minus, well, we can do two minus. We can do either minus the min and the max, or we can do minus the min minus the max, but we'll do this here. So we're going to take our total and we're going to remove the minimum and the maximum value, and that gives us a new total. And again, we'll just be returning this total divided by our length of our salary divided or minus 2. So let's see here. I'll do this. So it's going to be length of our salary minus 2. Now, I'm calling length twice here, so I can actually make this a little bit more efficient by doing max index minus 1. But I'm going to leave it the way it was because it's a little bit more clear this way. All right, and then the last thing we need to do inside of this loop is we need to update our index. So index will equal our index plus 1. All right, so this should do it. We're going to have a total, we're going to have a minimum value, which we set really high to begin with, and we have a maximum value, which we set really low to begin with, and we have our current index. Then while our index is less than the maximum index in our salary array, we'll just grab the salary at that index, we'll update our total by adding the salary, we will check our minimums and maximum values, possibly resetting them to this new value if this value is less than or greater than our min or max, and then we have to update our index here to make sure that we keep going forward through our loop. Finally, at the end, we take our total and we remove the min value and the max value from it. And we find the total values so far minus 2 because we removed two values, the min and the max. And then we just return our total divided by the number of values. That's the definition of the average. So let's see how we do. And it works. Let's see if we do any better than our one-line solution. Well, it's about the same. Actually, I think it's exactly the same. 5.49 and 8.21, it's exactly the same. So all of this code, which makes it very clear what we're doing, gives us the same runtime as this one-liner. Okay, so that's about it. You can do this in many other ways. There's a lot of little things you can do. If you wanted to go through and sort of try to tweak this and optimize this, you could try making this a for loop. You could try doing things like plus equals. So I guess I'll go through a little bit and make a few changes here. So one thing we can do, this total, we're saying total equals total plus value. You could say total plus equals value, which will do the same thing. This plus equals will take whatever's on the left-hand side and just replace it with that plus whatever's on the right-hand side. So total plus equals value. Let's see, we can do the same thing down here with our index. Index plus equals 1. And we can do total minus equals down here. And this guy, instead of calling length again, we will try this trick where we just use the max index minus 1. Because the max index is already the length of salary minus 1. So length of salary minus 2 is just max index minus 1. And then we'll close up some of these spaces. Sometimes that helps. It makes it a little less readable, but sometimes it does help. All right, let's give this a shot. It's exactly the same, makes zero difference in terms of runtime. Okay, one other thing that we could try. Now this is going to be a little bit different, so I'll remove this entire thing. So with the one-liner solution, I created an array that was sorted of all the salaries. I just used slicing to grab everything after the first element up to, but not including the last element. So we can do something very similar here where we can have sorted salaries. So we can either slice it or we can use pop to remove certain elements. So we can say sorted array. So we can pop at index 0, which will remove the first element. And we can pop at -1, which will remove the last element. So that's the removing of the minimum, and we remove the maximum. And that actually changes the length of the array. So we can return at this point the sum of our sorted salary and divide that by the length of our sorted salary. So it's a little bit cleaner in the sense that we don't have to do any -2s here, and we don't have to do slicing inside here. So this should do it. All right, and it still works. So again, this one, we're sorting the array, then we're popping the first element, meaning we're removing the minimum value, and we're popping the last element, which means that we're actually removing that maximum value, and then we're just summing the array and dividing it by the number of elements in the array. And it does exactly the same. Makes no difference in terms of our runtime. Okay, so what else could we do? Well, one thing that's taking time here is this sorting. Now, you might notice in one of our solutions, we didn't actually sort the array. When we went through with our loop, we didn't actually sort the array itself. We didn't need to, because the loop, we were keeping track of the minimum and the maximum. So instead of sorting the entire array, we could just find the minimum and the maximum values and remove those. So one way to do that is just taking the, let's see here, we'll remove this. So we could say min value, that's the salary. That's just min of salary. Now this is a Python method, so not every language will have this. Same thing with this. So our max value will equal the max of our salary. So this will actually find the minimum in the salary array and the maximum in the salary array. And then we can just remove those from the salary array. All right, now one thing I will note here, I don't like modifying the inputs. Now this input is passed by reference, which means that the salary that we're working with here is the exact same place in memory. It's the exact same salary that gets passed in. So if we make changes like this, where we're removing the min and max, any other functions that are using this same salary object will have their min and max removed, which is generally not something that you want. So I don't like doing something like this. So let's make a copy. So we can do that by doing salary.copy, and then we can just work with our salary copy here. And then at the end, we can do the same thing we were doing with the sorted. We can just sum the salary copy and divide it by the length of the salary copy. See if that makes any difference. No difference at all, exactly the same. So again, this one, we're going through, we're making a copy of our salary array. We're just using the min function to find the min value and the max function to find the max value. Then we're calling the remove function on the copy to remove those values from our array. And then we will return the sum divided by the number of elements. Now, if we don't make a copy, this might save us some time in memory because we're modifying the input directly. Again, I don't like doing this. I don't recommend doing this, but for the demonstration, I'll just try it out. And in fact, it makes no difference at all. We get the same runtime and same memory footprint. So by modifying this input value, it doesn't actually save us anything in this case. All right, so I could keep going. There's a bunch of different things we can try with this, or a bunch of things we can play around with, but this is the gist of it. You get it. I think you understand. So that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.